Hello everyone. I know that the lunch is coming and you're probably hungry. I will try to be as fast as possible, but still not enough fast in order to understand something. You already know who am I. Today I will speak about the enterprise blockchain on Corda. In the previous presentation, you have some sort of understanding what Corda is, but I will go more deep on that. Okay. You heard that I'm the head of engineering of INDUSTRIA Technology. INDUSTRIA Technology is a company with 20 years of experience. We worked on with financial institutions, and now we are focusing on enterprise blockchain, confidential computing, and others. In that direction. Okay. In the last presentation, there was some discussion about public versus private blockchain. I will also go a little bit deep on that. On the left image, you see an example of traditional public blockchain on which all nodes are connected. All nodes have all the information on the ledger. They have everything. This was, let's say, not very suitable for the enterprise. And on the middle, you can see the example of first level of private blockchain, where basically different networks segregated from each other were developed in order some companies to speak between each other. But if the same company need to speak with a company that is not on this network, need to bring another node on the different network to speak with the other company. Corda, on the other hand, is promising to deliver a network where all participants can be in the same network connected, and they can have the privacy of data like these networks on the first level, on the first iteration of private blockchains, but everything on the same network. We will see how this will happen in a bit. Okay, comparison with public blockchain. In the public blockchain, normally you don't have identity. This is by design because everything needs to be anonymous. But for the enterprise world, this is not the case. If there is a malicious actor in the real world, you can sue them on court. On public blockchain, you can do that. In the public blockchain, you don't have finality because the longest chain wins. And at a given point of time, you don't know if your transaction is on the longest chain or not. You don't have privacy because everything is visible in the public blockchain. And in some situations, the public blockchain is not so easy to use for the, let's say, enterprise world because it is using technologies which are not proven. The tooling around them is not mature enough, and it's hard for the enterprise to adopt these technologies. And because of this thing, Corda was developed. And one of the core developers of Corda was actually a person who communicated with Satoshi Nakamoto and who was one of the early contributors of Bitcoin. But after the realization that the public blockchain is not suitable for the enterprise, then together with R3, he joined the R3 and they developed the Corda platform. This was in 2014 somewhere. Okay, the Corda network. As I said before a few slides, in the public blockchain, you don't have identity. On the Corda side, on the other hand, each node have a certificate. And in this certificate, it is bound to a legal entity. You need to be a legal organization in the real world in order to have Corda node. The organization is going through a KYC process in which their identity is verified with the authorities, and then the certificate is issued. From that point on time, all the transactions made for this node are signed with this certificate. And if the node is doing something malicious, there are traces, and the legal actions can be taken against it. Okay. The other thing is that the information on the Corda network is the communication is peer-to-peer, and information is stored only on the votes of the nodes that need to know about that information. It's not distributed across the whole network. In this example, you can see that the Titan technology is transacting with Bait Transcorp, and only they know about some asset, for example. DACMA International doesn't know anything. The consensus in the network is happening through the mutually distrusting nodes running Byzantine fault-tolerant consensus, which is the notary pool. The notary pool is used to ensure the finality of the network, and this way we will not have the problem that we have in the public blockchains. And this way, the Corda platform is ensuring identity that the enterprise needs, ensure the finality that also the enterprise needs, the privacy, because information is not shared between all the nodes, but only the nodes that care about, and it's easy to use by the enterprise because it's using the proven technology. The Corda is JVM based. It's written in Kotlin, but you can write your Corda apps in Java if you don't know Kotlin. Okay, now I will speak about the Corda features needed, or the most important Corda features that every developer needs to know about in order to create Corda applications. We can name these Corda applications Corda apps, like the distributed applications that you know, but because they are for Corda, Corda apps. The main features of Corda needed to develop a Corda app are states, contracts, flows, and obviously the transactions. Let's start with states. What are states? States are immutable objects that represent on-ledger facts. What can be these facts? These facts can be anything. They can be your amount in the bank account. They can be your agreement between you and someone else. They can be the fact that you own some asset. They can be everything. They're immutable, but in real life, the stuff can change. Your amount in the bank account can change because you make some transactions. Your ownership of some asset can change because you sold the asset or you buy the asset. Agreement between you and someone else can also change. And these facts need to be stored on the ledger. In order for this to happen, we evolve the states by marking them as historic, no longer valid, and create new state which is referencing the old one. This is how we construct a chain of facts. How we can construct these states? We can construct them through transactions. What are transactions? They are simply proposals for a ledger update. When one node is proposing an update, this update needs to be, before to be stored on the ledger, need to be first verified. The verification is happening through contracts, and also the transaction need to be signed by all the required parties that need to know about it. As you can see in this example, I can point, yeah, okay. The new transaction, we have input states, we have output states, and the input state is referencing to the output state of the previous transaction. This is how we can construct a transaction chain. And the contracts. Each state is bound to a contract. In order state to be created or to be redeemed or to be changed, this needs to be validated by a contract. And only one contract is responsible for changing the state. In one transaction, you can have more than one contracts because you can have different type of states in the same transaction. The contracts, as I said in the beginning, they're written in Java or Kotlin, but they need to be deterministic. What does it mean? This means that the contract logic should care about only the data inside the transaction and nothing else. The contract should not make HTTP calls, should not read the environment, should not read files from the file system. Only the data inside the transaction. This will ensure that no matter in what point in time the contract logic is executed, it will give the same result. In Corda, there is a deterministic Java virtual machine which will ensure that you are not using Java functions that will make your contract code not deterministic. Okay. And the transactions are created through flows. Flows are a very interesting feature of Corda. They're used to automate the process of agreeing ledger updates. They're the only thing, or the only way how the nodes can communicate between each other. This is the logic of one flow executed on one node. This is the logic of another flow executed in the second node. And this is the logic executed in the notary pool. The interesting thing, okay, and the other thing is the communication between the nodes. The interesting thing about the flows are that they can suspend. At this moment of time, when the first node is sending data to the second node, after the data is received, the first node is suspending the flow. This suspension can be for hours, days, weeks, or even months without problem. And when the flow needs to be, let's say, resurrected from that, this will happen without problem. Which allows the code to have started many flows in parallel, but to not take to not use resources for them for actual running. The resources are used for actually running flows. Corda is providing built-in flows for automation of the common tasks like collecting signatures, recording the states on the vote, communicating with the notary, and so on. And this is a, let's say, typical Corda architecture. We know that the technology behind is good, but as we know on the public blockchain, the users need to interact with it somehow. And how they can interact in the world that we live, normally this is happening through web interfaces. We can have some web API in front of our Corda node that will respond to the HTTP requests. This HTTP API is connected to the Corda flow through the RPC interface exposed by the Corda node. The HTTP request will be transformed into execution of the write flow installed on the Corda node. This flow will start the process described earlier on. That will initiate the transaction, sign it, send it to the other node. The other node will do some logic, return the response. Then we can validate the signature of the other party. Then the information is sent to Notary and so on, recording to the ledger. Through the RPC, the API interface is receiving this update and can return HTTP response to the actual user interface used by the user. This RPC interface is generic, and you can create eventually a desktop application if you want. Whatever you want. And if you have time for questions, you can ask.
Thank you. This was very interesting and informing. You mentioned about privacy, but if the transactions are validated by the notary pool, how is this private? So the notary pool knows about the transfer between A and B, right?
Yes, the notary knows about that some transfer is happening, but there are two types of notaries. There are validating and non-validating notaries. The validating notaries can read the data in the transaction, but you need to trust them somehow. The non-validating notaries don't validate the actual transaction by executing any contract code. They're just preventing double spending. What does it mean? That the same unconsumed output state is not used in another transaction. In future, by using the conclave technology, another product developed by R3, they want to put it inside the Corda node, and this way, with confidential computing, to have validating notary, that the owner of the validating notary to not have access to the transaction itself. But this is for the...
This is the next step.
Yeah, this is the next step.
Thank you.
Any other questions?
Hi, Venko. We are co-workers. I just want to assist him that he can mention some cool features on Corda, how scalable Corda is, and how you can upgrade Corda apps, and such kind of how Corda application is structured. Just pretty short to mention those scalability and upgrade features.
Yeah, let's say in continuation with the topic that Professor Thompson, if I'm not said about, and the question that was somewhere from there about the upgrades. In Corda, the Corda apps are signed and also have a version. And in the contract logic, you can define which certificate this contract is signed in order the Corda node to allow communication between two nodes, and also which version of the Corda app is used. This way, you can make your Corda app to work, let's say, with 2 or 3 versions which are next to each other, but to reject communication with older versions of the Corda app. But to be used to upgrade states from old contract to the new one. This way, if there are some error in the old version, to make a contract upgrade, to which all the parties using this particular type of states to upgrade their state to the new one, to use the newer version of the contract. let's say. Anything else? If there are nothing more and you're hungry, probably we can go to lunch. These are my details and the details of our company. If you're interested, you can look at our website. We are hiring. Thank you very much.